The most expensive architecture mistake isn't downtime. It isn't security. It isn't even choosing the wrong cloud provider. It's building complexity before you've earned it. Welcome to this explainer. I am so incredibly excited to share this with you today because we are tackling something that haunts almost every single engineering team, startup, and enterprise in the world at some point. When you think about massive engineering failures, right, your mind probably jumps immediately to the high-profile stuff. You think of massive data breaches, catastrophic server outages that make the front page of the news, or maybe a huge cloud migration that completely botched the company's quarterly earnings. But the truth is, those aren't the most expensive mistakes. The real silent killer in software engineering is much more insidious. It's that urge to build an incredibly complex system long before the business actually demands it. This right here is what we're talking about, building complexity before you've earned it. Every single day, thousands of companies accidentally waste millions of dollars. And honestly, even worse than the money, they completely burn out their absolute best engineers. Why does this happen? Well, it's because they are frantically optimizing for completely imaginary future problems instead of just solving today's actual business needs. They sit in a room, they look 5 years down the road at a massive scale they haven't even come close to achieving yet, and they start building an engine so heavy, so incredibly intricate, that the car can't even move off the starting line today. We see this over and over and over again in the industry. So today, we are going to break down exactly why this happens, how you can spot it in your own teams, and most importantly, how to fix it before it drains your runway.
Okay, let's dive into this. Here is what we'll be covering in today's explainer. First, the trap of overengineering. Second, the danger of premature scaling. Third, the FOMO technology chase. Fourth, the burden of complexity debt. And finally, number 5, optimizing for simplicity. Let's jump right into Section 1, the trap of overengineering, or applying massive enterprise patterns to early-stage startup problems.
You see this stark contrast all the time, especially if you've been around the startup ecosystem or new innovation labs within larger enterprises. On the one side, you have the fantasy, right? You have these highly talented engineering teams standing in front of whiteboards, sketching out these beautiful architectures designed to handle millions of concurrent users. They are breaking their application down into dozens of microscopic, highly decoupled microservices. It looks amazing. But then on the other side, you have the harsh reality. The actual product they are building is currently only reaching a few thousand users, or maybe in B2B cases, just a handful of paying customers. When you apply these massive complex enterprise patterns to early-stage startup problems, it's literally like trying to use a commercial wrecking ball to crack a walnut. I mean, sure, you might eventually get the job done, but you essentially pour wet concrete over your team's ability to move quickly. In these high-uncertainty environments, simple, monolithic systems almost always outperform complex distributed ones. Why? Because simple systems allow you to pivot. They allow you to adapt and iterate based on actual customer feedback, rather than forcing your team to spend all of their sprint cycles fighting with their own infrastructure.
That leads us perfectly into Section 2, the danger of premature scaling, which is essentially building out massive infrastructure before you even have product-market fit. We are talking about engineering teams dedicating months, and I mean months, of highly expensive, incredibly valuable engineering time to spinning up complex Kubernetes clusters long before they have ever achieved true product-market fit. It's wild when you step back and look at it. They are building a 10-lane superhighway for a town that currently only has 3 cars driving around. They're in meetings designing for 100 million users when the database currently holds exactly 500. They are creating these elaborate, multi-region, active global architectures when they literally do not have a single international customer yet. And the irony here is just painful. Engineers do this because they want to go fast in the future. They think, if we build this now, we'll be ready when the viral spike hits. But scaling too early is actually the absolute #1 thing that slows down your delivery today. Instead of shipping the actual features that might win you those international customers, your team is bogged down in the weeds of global data replication latency and consensus algorithms. You are actively starving your actual, real-world business today to feed an imaginary one in the future. Which brings us to our third pitfall. Section 3, the FOMO technology chase. This is when teams select tools for their resumes instead for actual business value. This is a very real, very human psychological trap that we often jokingly call resume-driven development. But it's a serious issue. It happens when engineers and architects start choosing technologies not because they solve a critical, immediate business problem, but simply because of the fear of missing out, FOMO. These tools are currently trending on tech blogs, or maybe half the team just came back from a massive tech conference and everyone there was talking about them. So you walk into a company, and what do you see? They are deploying a highly complex service mesh for just 3 services. They're going all in on wildly fragmented serverless architectures. They're setting up immense Kafka event streaming clusters, building bespoke AI infrastructure from scratch, or attempting these massive multi-cloud strategies. Now let's be totally clear here. These are phenomenal technologies. They are incredible tools, but they are adopted over and over and over again without any real business requirements to actually justify them. A team will adopt a multi-cloud strategy just in case AWS goes down, completely ignoring the fact that building a multi-cloud architecture literally doubles their operational overhead, doubles their development time, and halves their feature velocity. They are selecting tools to pad their resumes and feel cutting edge instead of driving true measurable business value. So the crucial point is summarized perfectly right here in this quote. Architecture should solve today's problems while making tomorrow possible, not today's architecture solving tomorrow's imaginary problems. Your job as an architect, as a CTO, or as an engineering leader isn't to be a fortune teller. You aren't supposed to predict the future with perfect accuracy. Your job is to build a system that is robust enough to handle exactly what you are doing right now, while remaining flexible enough and, frankly, simple enough that when tomorrow's reality actually arrives, you can easily adapt to it. If you try to solve tomorrow's imaginary problems today, you usually just end up creating entirely real, massive problems for yourself in the present. Let's move on to Section 4. The burden of complexity debt. This right here is the true silent killer of engineering speed.
We all know about technical debt, right? Writing messy code to get a feature out the door quickly so sales can close a deal. We have all been there. But complexity debt is often far more dangerous. If technical debt is a messy room, complexity debt is a house with 30 tiny rooms, interconnected by secret trap doors, and a plumbing system that absolutely no one in the family understands. People so often forget that microservices and distributed systems are not free. Every single time you split a service or add a new layer of infrastructure, look at what you are adding to your plate. You have to set up brand new monitoring and alerting dashboards. You have a completely new security perimeter to defend. You have network latency and failure retries to manage, because networks fail. You need new CI/CD pipelines. You have to manage IAM permissions for that new service. You need more documentation. You have a higher operational cost in your monthly cloud bill. And most importantly, you add an enormous cognitive load to your engineering team. This complexity doesn't just add up linearly, it compounds exponentially over time, until your team is crawling at a snail's pace.
I want you to really think about this quote. Every layer you add is another system someone has to understand at 2 a.m. Put yourself in this scenario. Imagine your pager goes off in the middle of the night. It's 2 a.m., the system is down. Real customers are actively angry and opening support tickets. If you have a simple architecture, you wake up, grab your laptop, look at the centralized logs, find the bug, roll out a fix, and go back to sleep. But if you have a massive, over-engineered web of dozens of microservices, service meshes, distributed tracing, and event queues, you are suddenly playing a terrifying, high-stakes game of murder mystery at 2 a.m. while your company bleeds money. You're trying to figure out which of the 40 services dropped the message. That right there is the human cost of unearned complexity. And the truly terrifying part of all this is, complexity is easy to add, but incredibly expensive to remove. It only takes a couple of weeks, maybe a sprint or two, for an eager engineering team to spin up a new Kafka cluster and start breaking apart a monolithic database. It feels fast, it feels productive. But once that system is actually in production, once real customer data is flowing through it, once 3 other downstream services depend on its exact data format, ripping that complexity back out can take months or even years of painstaking, delicate, incredibly risky work. You literally become a prisoner to the architecture you built. Let me give you a real-world consulting example of what this looks like in practice.
So we get called into a startup that is really struggling. They are struggling to release new features, they are burning through their venture cash, their engineers are miserable and threatening to quit, and the founders ask us to come in and audit their systems. We sit down, we look at their tech stack, and honestly, on paper, it is a masterpiece of modern cloud engineering. It's beautiful. They have dozens of microservices perfectly decoupled by domain. They are running heavily customized Kubernetes clusters. They have a service mesh routing all their internal traffic. They're using advanced event streaming for all asynchronous communication. And they've had to implement full distributed tracing just to figure out how a simple user login request travels through this absolute maze of a system. Looking at the architecture diagram, it genuinely looks like they are ready to compete head-to-head with Netflix or Google.
And this brilliantly illustrates the tragedy of the whole situation. We sit down with the founders, we look at all this magnificent, enterprise-grade, highly scalable architecture, and we ask the million-dollar question. So, how much traffic is this handling right now? And the answer is fewer than 5,000 total users. Not 5,000 concurrent users a second, 5,000 total users registered in their database. They have literally built an interstellar spaceship just to drive down to the local grocery store. Almost all of their engineering effort, all their brilliant minds, are going towards just keeping this massive, complicated machine running, which is exactly why they don't have the time or the resources to actually build the product features that would attract more than 5,000 users in the first place. It is a vicious cycle.
Which brings us to our final section, Section 5, Optimizing for Simplicity. This is the true measure of architectural success. So how do we break this cycle? We do it by fundamentally shifting our mindset and optimizing for simplicity above almost everything else. The most successful tech companies in the world, the ones that actually scale gracefully from a garage to a global enterprise, they don't do it by building massive distributed systems on day one. They do it by intentionally staying as simple as possible for as long as possible. They willingly endure the slight discomfort of a monolithic codebase until it absolutely screams to be broken apart. They earn their complexity. We really need to redefine how we measure a good architect and a good architecture. Mediocre architecture is measured by how many trending technologies are used. It's an architecture diagram that looks incredibly complicated and impressive on a conference screen. But brilliant architecture, good architecture, is measured purely by how quickly and safely teams can deliver value to the customer. The best architects in the world are fiercely, ruthlessly protective of simplicity. They're the ones in the planning meeting saying, no, we don't need a microservice for that. Let's just add a new table to the existing database. They optimize for fast feedback loops and incredibly low cognitive load for their developers.
I want to leave you with this defining thought to really cement this mindset shift for you and your teams. The architecture that wins isn't the one with the most services. It's the one that keeps solving business problems with the least necessary complexity. Complexity is not a badge of honor, folks. It is a tax. It is a heavy tax on your future execution and your future velocity. The entire goal of software engineering is to solve business problems, not to create an elaborate playground for infrastructure experiments. If you can solve a massive, multi-million-dollar business problem with a simple, boring, thoroughly understood technology stack, you haven't failed as an engineer. You have actually achieved the highest level of mastery. So as you go back to your desk today, as you look at your next sprint plan, or as you sit down to whiteboard and design your next big feature, I want you to ask yourself and your team this very tough, very honest question. Are you actually solving today's business problem, or are you just adding to tomorrow's complexity debt? Be ruthless about protecting your simplicity. Earn your complexity. Thank you so much for joining me for this explainer. Keep building smart, stay focused on value, and I'll see you next time.